Welcome back to the series of videos giving a general introduction to software and hardware co-design. This is the third installment and will continue from the second video that discussed approaches. In this video, we will look at the intentions and models of software-hardware co-design. Namely, we will focus on the major intentions of co-design and discuss the double roof model. The objective for this video is that you learn about the major intentions of co-design, specifically through using the interpretations of the syllable co of co-design, namely coordination, concurrency, correctness, and complexity. In addition, I will briefly introduce you to the double roof model used to cope with increasingly complex design of hardware systems. As today's co-design depend heavily on interdisciplinary design groups, coordination refers to the ability the group has to perform the design steps when including firmware, operating systems, and application developers representing the software side, while hardware developers and chip designers represent the hardware side. They have to coordinate and work together on the system as a whole. The second point includes concurrency. This derives from the extreme tight time-to-market windows that has led hardware and software developers to discontinue their practice of initiating the firmware and software development only after the hardware platform is available. Instead, both platforms are developed concurrently. This way, co-design has contributed significantly to bypass this bottleneck of doing developments sequentially by starting from either an executable specification or applying virtual platforms or prototyping to achieve concurrent development of software at an early stage prior to the finalization of the hardware platform. Moving on, the third point is correctness. This includes co-verification of hardware and software interaction and integration due to the complex techniques used. Consequently, the fourth point refers to complexity. Today's electronic systems design is highly optimized and must adhere to a variety of requirements such as cost, power, and performance. Various models have been developed to categorize and identify hierarchical design problems such as the double roof model. This is to cope with the ever-increasing design complexity of hardware systems. The model is a synthesis-oriented model, where one part of the roof represents abstraction layers, often encountered in hardware design, while the other side of the roof represents those typical to software synthesis. The double roof model has a two-layer roof, where the top roof represents the behavioral layer, while the lower layer is called the structural layer. That's it for this video. Thank you for your attention.